Hello and welcome to this video where we calculate the number of cells or perhaps 18650 cells we need to build a 12.6 volts 200 ampere hour battery bank. And to make 12.6 volts 200 ampere hour battery bank from 18650 cells, we have to stack up 3 cells in series. As you can see with this battery configuration here, we've got a 3S configuration. So this is the first cell pack, which has a peak voltage of 4.2 volts, and same goes for the second and the last cell packs. So since you've got 4.2 volts on each of your cell packs, you'll have to wire 3 cells in series, as you can see here, to get your 12.6 volts here. So the positive connection of the first cell pack to the negative of the second, and the positive of the second to the negative of the last cell pack. And if you measure voltage across here by having the black probe of a digital multimeter here and the red probe here, what you get is 4.2 volts. And if you go across the second cell pack and you measure voltage here by having your black probe here and red probe here, you got 8.4 volts. Then across the last cell pack with your red probe here and your black probe here, what you get is 12.6 volts. So this serial connection of 3 cells gives you 12.6 volts, but the battery capacity remains the same, which is 2.6 ampere hours. Assuming each of the cells we're using for this battery build is rated 2.6 ampere hours or 2600 milliampere hours. So by doing this connection, you notch up the voltage, but the battery capacity remains 2.6 ampere hours. So what we want to do, to get 200 ampere hours, 12.6 volts, is stack up enough cells under each of the cell packs. By having enough cells under each of the cell packs to give 200 ampere hours, then we can successfully make a 12.6 volts 200 ampere hour battery. For that, we do a simple calculation. Now that we have the cell rating for each of the cells we have, to get the number of cells we need. So we divide a 200 ampere hour battery, which is the proposed battery capacity, by the 2.6 ampere hour cells, each cell. Then we get 77 cells for each of the battery pack. And if we multiply this by the 3 cell packs we have here, we got 231 cells as the total number of cells we need for this battery build of 12.6 volt 200 ampere hour battery. Sometimes you don't have all cells having the same rating of 2.6 ampere hours. Maybe some of your cells are rated 2.6 ampere hours and you've got 2.8 ampere hours, you've got 3.2 ampere hours. But you want to stack up the cells in such a way that you have the same voltage and current across all the cell packs, because that's one of the rules of thumb for wiring batteries in series, or wiring battery packs in series. So this pack should have a peak voltage of 4.2, and here 4.2 volt, 4.2 volt. So you want to have the same voltage across the cell packs, and same goes with the battery capacity. You want to ensure that the same battery capacity you have here is what you have here and here. So that's why when wiring cells of different capacity, you want to make sure that if, for example, as the case with what you can see here, you've got 2.6 ampere hours here, then you have a 2.6 ampere hours here, 2.6 ampere hours here. Same goes with the second line of the battery arrangement. And on the third line of the battery arrangement, here you've got 2.8 ampere hours. And here you have 2.8 ampere hours, 2.8 ampere hours. 3.2, 3.2, and 3.2. So if you continue to stack up your cells this way or under each of the cell packs, by making sure that what you have on a given line for cell pack 1 is what you have for cell pack 2 and cell pack 3, you can ensure some level of balancing of voltage and capacity across the entire battery bank or across the cell packs. So this is basically how you wire cells of different capacity to achieve a 12.6 volts 200 ampere hour battery bank. And as you continue to do this, you continue to add up the current of each of the cell packs, since you can't just take 2.6 ampere hours and perhaps or perhaps you can divide 200 ampere hours by 2.6 ampere hours, because you aren't working with cells already at 2.6 ampere hours here. So what you have to do is sum up the current on the current of all the cell packs, or sum up the capacity of all the cell pack you have on each of the sum up the capacity of the cells you have under each of the cell packs to get your 200 ampere hours. And if you have 200 ampere hours here, 200 ampere hours here, and 200 ampere hours here, then you wire the cells or the cell packs in series, you get your 12 volts 200 ampere hour battery bank. And for the BMS, because understanding the wiring of your battery bank, or perhaps knowing the configuration of your battery bank, can come pretty handy in correctly wiring your BMS to your battery bank. And because we know we've got 4.2 volts here, we've got 0 volts here, we've got 8.4 volts here, and 12.6 volts here, we can easily wire it to this BMS, on which you've also got 4 connections. So you have 4.2 volts, which is on some BMSs you see it labeled B1, because you don't have this so you've got B1 here. On some BMSs you don't see 4.2 volts, you see B1, you see B2, B minus, and B plus. Your B plus is your 12 volts connection from the battery bank, or the positive connection of the battery, and the B minus is the 0 volt or negative connection, and B2 is for 8.4 volts, B1 for 4.2 volts. And you wire B minus from the battery to B minus on the BMS, and B1 to 4.2 volts, and 8 volts to B2, or B2 to 8 volts, or B2 on the BMS. And the positive connection of the battery comes to the 12.6 volts, or B plus, on the BMS. Then for this BMS, we've got 2 connections for input and output labeled C and D. So this is D minus and plus, which is how you discharge your battery bank. This is the output, and you hook your load to the battery via this connection. And here you have C minus and C plus for charging. So through this connection, you can charge and discharge your you can charge your battery bank, or perhaps you can wire the wire from your solar panel, your charge controller, or your charger to your battery bank. And in some cases, you have BMSs not having 2 connections for input and output. So you have just 1 connection for input and output labeled minus and plus, maybe P minus and P plus. So you have to split these connections, this connection into 2 connections, so you can have 1 for input and 1 for output. As you can see here, we have a minus, we have plus. So we split the minus into 2. Here we have a P minus, we have a C minus here. This is power minus, this is charge minus, and this is a power plus, this is a charge plus. So these 2 connections here will give you your input, or perhaps our charge, and these 2 connections down here gives you your output or discharge. So this is basically how you calculate the number of cells you need to build a battery bank using 18650 cells. And if you want to properly wire your BMS to your battery bank, you also have to understand the configuration of your battery bank, like what connection is what. So knowing which connection is 4 volts, 0 volts, 8.4 volts, and 12.6 volts can come pretty handy in wiring your BMS correctly to your battery bank. And that's all for this video. Thanks for watching. If you want to see more videos like this, please subscribe to the channel and keep the video notification bell turned on. So bye for now.